So 27, they give you this kind of long and complicated circuit. They've got this picture. This picture is going to get very, very busy. So write big. That's our circuit. We have an E1, we have R1, we have R2, we have E2, we have R4, we have R3, and we have R5. This is my circuit. What they ask you to do is find what R5 is, and they give you some values. They tell you some of the numbers that we have in this. They tell you R1 equals R2 equals 2, R3 equals R4 equals 4. They tell you E1 equals E2 equals 10. They tell you to find R5. So at this point, based on what they asked us, how many equations would I need to solve this? How many unknowns are there? Right now there's only one. But to solve this, we need to use the junction rule and we need to use the loop rule. So for the first step in solving these things, we write the junction rule. How many junctions do I have on this? How many places do currents split off?
3.
I see 3 junctions. The vertices of these the triangle. One junction here, one junction here, one junction here. So I need to draw currents to connect all those junctions. I can draw one current. Goes from here all the way up to here. That's current. I'm going to call that I1. Why did I call it I1? Because it's going through E1 and R1. Does it matter what I call it? No. You can call it whatever the heck we want. Okay? I have another current. So this current is going to split off. I have some current going in. So now I can have some current leaving. Let's do current R2, going through R2 and E2, that little piece of current. So it starts at the junction, and then it goes around until it hits another junction, and that's where it stops. What should we call that current? I2.
I'm sorry.
That's okay. I like ice cream too. If there was some congressman that's saying that they're trying to ban ice cream. Have you seen this? Has anybody heard of the Green New Deal?
Oh,
Yeah. And their argument against it is that they're trying to that they're trying to get rid of ice cream. You can't eat ice cream if we do the Green New Deal. And that they're going to kill all cows because they fart too much. They fart too much. These are the summaries that I saw in the Green New Deal.
Summaries, are they right?
So I've entered this junction. So I have current going into the junction, I have current leaving the junction. I'm safe with this junction. This junction's fine. I can do whatever I want for these two paths. Now I'm at this junction. I have current going in. So what do I need going out of this junction? I need to make sure I have some current going out of the junction. So I can, maybe this bottom line here, I can draw another current. So let's draw another current for the bottom. Face melting yellow current. I5. Okay. Why did I call it I5?
Yeah,
By R5. Duh. Okay. So I have current going into this junction. I5 is going in. I1 is leaving. So I'm good with this junction. I'm good with this junction. I'm good with this junction. So it doesn't matter what direction I put for these two. Well, I have this little path. The current can go through in this little path. Doesn't matter. I could pick current going up, or I could put it going down.
Does the other one have to be opposite?
Doesn't matter. As long as I have current going in and current going out. So to be consistent with what I've got written on my solution, we're going to do, oh goodness, how do I pick a different color? Okay, so we'll do I3. Yeah. And then what color do we want for the last one? Green? Okay, I've got green, so let's do green. I4. Okay. Now how many unknowns do I have?
Oh, no, the eyes.
I don't know any of the eyes. How many eyes are there? 5. So now I need to find I1, I2, I3, I4, and I5. So how many equations do I need? 6 unknowns, I need 6 equations. As long as I have 6 equations, I can solve them all at the same time, and I can get the final answers. It's a pain in the ass, but you can do it. Am I going to make you do this on an exam?
Yeah.
No. I guarantee I will not make you do this on an exam. It's too much. It would take you the whole time. It would take me the whole time to do this. It's a lot of algebra. You can do it. It's doable. It's just long.
So you won't put this on your
I will not make you solve for all of these.
Uh-huh.
What I might make you do on an exam,
Solve for 2.
write the appropriate number of equations that I could solve this. Don't do the algebra, just give me the equations. Okay, so let's do some equations. Let's do the junction rules. How many junctions are up there? I see 3 junctions. Sometimes the junctions are the same, sometimes they're different. If they're the same, they can't count, you can't have 2 of the same equation. But as long as they're 3 different equations, that would be 3 equations right there. And then how many loops would I need? I'd need 3 loops. 3 junctions would be 3 equations, and then 3 loops for 3 more equations. Let's do it. Let's do the junctions. What junction do you want to do first? Bottom corner, top, or
bottom left.
bottom left? What's going into that junction? I3. Anything else going into it? I5. Anything else going into that junction? You want ABC? Junction A. I3 plus I5. What's anything else going into that junction? No. What's leaving the junction? Okay. I3 plus I5 equals I1. Not too bad. Let's go up to the top junction. Junction B. What's going into junction B? I1. What's leaving? Anything else going into junction 1? Or junction B, I guess. What's leaving junction B?
4.
Looks like I2 is leaving. What else? I3 is leaving, plus I4. Seems weird. Can I have a junction where I have 1 current on one side and then 3 currents on the other side? Yeah, sure. As long as you have current going in and current going out. Doesn't matter. I can have 15 currents on this.
Wow.
I won't do that on the exam. You have recorded evidence. If I do it, bring back this recording and I'll give you all perfect scores on the next exam. Yeah, now you're all going to be hoping I do it. You're going to go in and change the copier so that it does it.
I'm going to try.
Okay, let's do part C. Ooh, you could pull it off. Now that we have to copy our own exams, you could manage it. Copy set is too expensive. Okay, junction C. What's going into junction C? I2 and I4? I2 plus I4. What's leaving that junction? High 5.
High five.
Okay. Are any of those three equations the same? No. They're all different. So that's good. We want them all to be different because they're all unique equations. So then how many more equations do I need?
3.
I only need 3 more. So how many loops do I have to draw?
3.
3 loops. This picture is about to get even busier.
What color are you using?
I don't know.
Like a light, like a baby.
Gray. Let's
Orange.
gray.
I like it.
Gray.
I'm using silver.
I'm going to do 50 different shades of gray and this becomes a completely different problem.
Alright.
Okay. Let's do one loop that goes all the way around the outer perimeter. So I'm going to start here and go all the way around the outer, all the way down, all the way. There's one loop. I'm going to call that loop number 1. Yes. Okay. It's not as bad if you look at the loops as you're drawing them. Don't try to draw everything all at once. Draw it step by step. So let's start with loop number 1. I usually start them on batteries. It doesn't matter where you start. I just like to start on batteries. I'm going up through this battery E1. I'm going from the negative terminal to the positive terminal. So am I adding voltage or subtracting voltage? Adding. So that's positive E1. And then my loop goes up, reaches this corner. Is this corner a junction? No, it's just a corner. Then I start moving to the right, and I pass through R1. Negative R1, why? Same direction as the current I1. So I have minus I1 R1. I keep going. I go through this junction, and I hit R2. Is it positive or negative? Negative. Why? Same direction as the current. So that's a negative I2 R2. I come down and I hit the battery. Am I going from the positive to the negative or negative to positive? Positive to negative. So am I adding or subtracting? I got to subtract. Minus E2. I hit the bottom corner. That's the junction. Big deal. I'm going to the left through resistors. That's the same or opposite direction? Same direction, so I subtract. Minus I5 R5. Then I hit that left bottom corner, and I go up, and I get back to my battery. So is that loop complete? So what does it equal to? Equals 0. Let's do another loop.
Yes.
Orange loop. Let's do a little orange loop. Let's do a loop in that corner. Loop number 2. Starting on the battery, I'm going this way through this loop. I'm going clockwise. So I'm starting here, I'm going up, I'm going over, then I'm going through this R3, and then back. Starting here, going up, over, down. I'm going through this top triangle. So I'm going from the negative to the positive side, so I'm adding. Adding. So I got positive E1. I hit the corner. I'm going to the right through the resistor, same direction as my current is going, so I'm subtracting. Minus I1R. These questions often make a lot of sense when you see me do them. You'll want to practice them on your own too. Then we go down to the left. That's the direction my loop is going. That's the same direction as the current is going. So that's minus I3, R3. And what does that equal to? 0. So that loop is done. Okay, what color should we do now? Pink?
Where's your red? It's down in the corner.
Pink. What loop do you want? We can do any loop that we want. I've got a loop that I drew, but we could do this triangle, we could do this triangle. That triangle? Okay, we'll do this triangle. Do you want to go clockwise or do you want to go counterclockwise? Clockwise. Clockwise? Okay. You want to go counter? Let's do counterclockwise for shits and giggles. Counterclockwise, so that's going to be like this. Okay, so I'm going to start down at this corner. I'm going counterclockwise, so I'm going up through the battery. I'm going from the negative to the positive side. Am I adding or subtracting that battery then? I'm going up through it. So I'm going to add the E2 plus E2. I'm going to come up. I'm going to hit this corner. I'm going to go to the left through resistor R2. What direction is my current going? Opposite direction. So I add that since they're opposite directions. Plus I2 R2. I hit this junction. I'm going to come flying down through the little offshoot. I'm going through R4 and going down through R4, same direction as my current. So I subtract that. Minus I4, R4. And what does that equal to? Equals 0. How many equations do I have now? 6 equations. How many unknowns do I have?
6.
6. I'll tell you what, if you take all this stuff home, use this is what I'd ask on an exam. But if you take this home and you can solve, bless you. You need to be blessed after you do this. If you can solve for I1, I2, I3, I4, I5, and R5, if you can do the algebra to get this, then I'll give you 5 points of extra credit on your next exam. It is not trivial. It is not easy. It will take several pages of algebra. Okay? And you have to be able to show me the work to do it. Yeah, Aaron.
So we can still use equation 1 even though it has like E1 minus E2, which would be 0.
Yeah.
Which is like substitute.
Yeah. Substitute all your numbers in and solve it. It does not become any easier by getting rid of those 2 numbers. It's tough. Okay. Any questions on that? No? All right, let's do another problem. Let's actually, if I gave you one to solve all the way through, it would be something more like number 29. So let's do 29. So 29 gives us a circuit as well. E2, R3, R2, R1, and E1. And then they tell us that we have I1 up here, I3, and I2. they give us some of these values. They tell us E1 equals 12, E2 equals 8, R1 equals 4, R2 equals 4, and R3 equals 2. So how many parts of this picture do I not know the answers? What variables are unknown? The i's. How many i's are there? 3. So how many equations do I need? 3 equations. Okay, so this is what you have to do. Find the current. They actually gave you 2 loops. They gave you this loop, loop number 1, and they gave us loop number 2. Okay. So they tell you to use these loops and find all the currents. So we need 3 equations. How do we get those 3 equations? What do we do first? Junction rule. How many junctions do I have? I see 2 junctions. Corners aren't junctions because the current doesn't split. Anywhere the current can split into multiple different directions. Those are going to be the junctions. So I have junction, we'll call them, you liked A's and B's, didn't you? We'll have junction A up here, and we'll have junction B down here. Let's do junction A first. What current is going into junction A? I see I1 going into junction A. How about junction, what's going out? I2 is going down, and I3 is going to the right. Okay. Can I plug in any numbers into those junctions? Nope. I can also look at junction B. Let's see if junction B is helpful. What's going into junction B? I2 is going down all the way through here into B. I3 is going all the way around into B, so I2 plus I3. What's leaving the junction? I1. Is that any different than junction A? I1 equals I2 plus I3. I2 plus I3 equals I1, which is the same. So how many more equations do I need? Still need 2 more, even though I have 2 here because they're the same equation. So I got to find 2 more equations. That's where my 2 loops come in. Let's do loop number 1. What is the equation for loop 1? Other thing to ask is, can I plug in any numbers here? Do I know any of these i's?
No.
Don't know any of the i's. Let's look at loop number 1. Where do I start? Start on the battery. Positive E1, because I'm going up from the negative to the positive. And then I'm going to the right through the resistor. What direction is that relative to the current? Same direction. So I subtract. And then what am I doing? I'm going through the middle. Same direction as the current. What current is that? I2. What resistor is that? Minus I2 R2. Then I reach the bottom, I go to the left, and I get back to my battery. So what does that equal to? 0. That equals 0. Can I plug in any numbers? Yeah, what's E1? 12 minus I1 R1. What's R1? 4. So I have 4 I1 minus I2 R2. What's R2? 4. So I have 4 I2 equals 0. We'll call that equation number 1. Okay. How many more equations do I need? 1 more equation. And that was hot purple. Come on, hot purple. There we go. Equation 2. I'm starting on the top of the battery. I'm going down through the battery. That's going from the positive side to the negative side. So what do I do with E2? I subtract it. Negative E2. And I go down, I reach the corner, I'm going to the left through R3. What direction is the current going through R3? Same direction. So this current goes all the way through, goes down, and goes over. So since it's the same direction, it's minus I3 times R3. I keep going around. What's the next thing I hit? I hit the battery. Am I going from the negative to the positive or positive to the negative when I cross it? Negative to positive, so I add E1. And then what do? Do I hit anything else? I hit R1. Am I going the same direction or opposite? Same. So I subtract minus I1 R1. I can plug in some numbers, can't I? What's E2? 8. So I have negative 8 minus I3 R3. What's R3?
2.
So that's minus 2 times I3 plus E1. What's E1?
12.
That's 12 minus I1 R1. What's R1? 4. I1 equals 0. Can I simplify this equation at all? Yeah, how can I simplify it? Negative 8 plus 12. So I have negative 8 plus 12 is 4. Minus 2I3 minus 4I1. Okay. Now what do I do? How many equations do I have? That's equal to 0.
You got 3.
I have 3 equations. How many do I need?
3.
I need 3 equations. So to do this, you have to start getting rid of variables. I'm going to see. Take what's that? See? No. Last time out. Okay. I want to get rid of some variables. First variable to get rid of is usually the one that you use in the junction. So I have I1 is equal to I2 plus I3. So anywhere I see an I1, I can put in I2 plus I3. So I'm going to substitute that anywhere I see an I1 in equation 1 and anywhere I see an I1 in equation 2. Yeah? So I plug those in. I2 plus I3 goes in for that I1. So I have now 12 minus 4 times I1, which is I2 plus I3 from the junction, minus 4 times I2. That equals 0. Let's keep solving this out. So I do 12 minus 4 times I2 minus 4 times I3 minus 4 times I2 equals 0. So I distributed the 4 into the i's. Negative 4 times I2, negative 4 times I3. This will really test your algebra skills. So I can combine the I2s. I have 12 minus, what's 4? Negative 4I2 minus 4I2. That's negative 8I2. Minus 4I3 equals 0. I'm going to solve it for I3. I'm going to get I3 by itself. I could solve it for I2 and get I2 by itself. The process would still be the same. I'm just going to do I3. So I do 12 minus 8 times I2 equals 4 times I3. So I added the 4I3 to the other side. Now I divide both sides by 4. And I find that I3 is equal to, what is that? 3 minus 2I2. Okay. So I have an equation for I3. And I want to do that same process for equation 2. So I have 4 minus 2 times I3 minus 4 times I1. Do I want to keep I1 in there? What do I replace I1 with? Replace it with I2 plus I3. And that equals 0. Then I'm going to do the algebra on this one. 4 minus 2I3 minus 4I2 minus 4I3 equals 0. 4 minus 6I3 minus 4I2 equals 0. How did I get 6I3? Negative 2I3 minus 4I3. Negative 6I3. What do I want to solve this for? Solve this for I3. If I solve this for I3, then I can set it equal this one, and then I'll have everything. I2 will be my only variable left. Okay. If I would have solved this green one for I2, what would I solve this for? I2. Okay. So that's kind of the process of thought that we follow in these. So I solve this for I3. 4 minus 4I2 equals 6I3. Divide both sides by 6. So I3 is equal to 2/3 minus 2/3 times I2. Yeah? 4 divided by 6 is 2/3, minus 4 divided by 6I2 is 2/3I2 equals I3. Now I can set these two equal to each other. Purple and green are equal. What color do I get when I mix purple and green? We're going to go with orange. Set these two equal to each other. So 3 minus 2I2 equals 2/3 minus 2/3 times I2. I hate fractions. How many of you hate fractions? Yeah. Plug in I3 right here. Or plug it in way up here.
Yeah.
You could. I find that less straightforward. You could do that. Okay. There we go. Fractions. Who likes fractions? Nobody. How do I get rid of fractions? I can multiply everything by 3. Yeah, they have the same denominator. So I just multiply the whole damn thing by 3. What's 3 times 3? 9. What's 3 times 2? 6. 6I2 equals. What's 2/3 times 3? 2. What's 2/3 I2 times 3? 2I2. Get all my I2s on the same side. And get all my numbers on the same side. 9 minus 2 is 7. Then I add my negative 6 over to the negative 2. Get 4I2. I2 is then 7/4. You can ask Google what's 7/4. It'll give you a decimal. 1.75 amps. Am I done? No. What do I have to do now? Plug it in? Plug it in where? Plug it in for I3. So I3, which equation should I use?
The green one. One without.
I use the one without fractions. Doesn't matter? It doesn't matter. You get the same answer. So I can do I3 equals 3 minus 2 times 1.75. And what do I get for that? If you plug that in, what do you get? Negative 1/2. We'll come back to that negative 1/2. And how do I find I1? Is I2 plus I3. I1 equals I2 is 1.75 plus I3, which is negative 0.5. So I get 1.25. Okay. That's all the algebra to solve. You can plug in I3s earlier, you can solve it different ways. This is the most straightforward way, at least amount of thought. Okay. I don't like thinking. Anytime I think too much, I smell burning. Burning. Now, what does that mean that the current is negative? Can current be negative? Yeah, current can be negative, but what does that mean if current is negative?
Your arrow was the wrong way.
Your arrow was the wrong way. So you just chose the current to go in the opposite direction from where it actually goes. So if we go all the way back to this picture, I've got my current going this way. If I get a negative current, that means the current actually is flowing the opposite way.
So I3.
I3 would be going the opposite way because it's negative.
So do you leave it negative?
Yeah. So that it's consistent with your picture. Because if it's negative, anybody that comes along and looks at this then knows, oh, the current was going the opposite way, they just picked the wrong direction. Follow all these conventions, and you'll be good. Then other people can come along and see what you meant. Yeah.
So something like that would be on.
Something like this could be on the exam. It's a lot of algebra. It takes a decent chunk of time to solve, but it's relatively straightforward. Okay. I'd give you a maximum of solving 3 equations at once. Right. Very likely, I would give you the current directions and the loops to use as well. Because then it's easier for me to check. If I let you pick your own stuff, you come up with all sorts of crazy stuff. You invent physics. Okay, any questions on this one? No? Okay, let me stop this. Okay. Your exams are graded. I cannot give them back. There are still some people that have to take a makeup. The makeup is different than yours, but I want to make sure that they don't know what was on this one, so they don't know what won't be on the exam. Okay. If you want to see your exam, you're welcome to come over and look at it during office hours. You can come over right now and you can see your exam, look at it, ask me any questions that you have. The average score was a 53. It's a bit lower than I'd like. There were some questions that make me question if I should do a curve or not. So I put some homework questions directly on there, and people missed those. Got no credit. I put a relatively straightforward resistor problem, and people completely missed that. So it makes me wonder if I should curve or not. I know that's what students say. My inclination now is to not curve, because you still have 2 more exams and a final that you can bring your grades up. If you look at what your grades currently are in the class, a lot of you, maybe you got a 40 on the exam, but your current grade in the class is like an 8 because you have high quiz scores, high homework scores, and high discussion board scores. So make sure you're submitting those homeworks and get your points. If enough people come and look at their exams and talk to me about their exams and think it was unfair and it doesn't accurately reflect what you learned, talk to me about that. I need to know that so that I can adjust. Right now my inclination is you maybe studied hard for the beginning and then you didn't study for the later chapters and you just didn't do as well. If you studied a ton and you still didn't do good, I need to know that, because then there's something that I'm doing wrong. But I'm not sure that I'm doing things wrong. Okay? But if a bunch of you tell me that I am, then I'll adjust things. Right. Okay. All right. You got about 5 minutes left. You can leave early.
Yeah, get my laptop real quick. Yeah. Make sure you bring it to class. And tomorrow or
How long will you be on campus?
Till 3, at least.